right. Well, we are just about 1 minute past our start time here. We've got our membership coordinator, Sarah, working in the background to see if she can get that ding dong turned off so nobody go running to the front door. That's just our additional participants starting to join. So good morning, good afternoon, good evening. Welcome to this afternoon's DNP Users Group Workshop, DER Cybersecurity Implications, IEEE P1815.2, DNP3, versus IEEE Standard 2030.5 versus SunSpec Modbus, friends or foes. This is the third installment in our Vision 2024 workshop series. My name is James Formea. I'm the Vice President of Education and Standards for the DNP Users Group Board of Directors. I'm excited to be your host for this afternoon session, and we're thrilled that you've all decided to join us. We really have an amazing panel of subject matter experts lined up for this session this afternoon. We're also really excited to have our expert panel chair, John McDonald, back with us again to lead this session. So before we kick things off, we do have just a few housekeeping items that we want to cover. And I'll ask Ron to pop those up on the screen for me there.
You bet. Coming right up.
All right. So first, we do want you to keep your microphones on mute unless you're speaking. We are going to open the floor at the very end of the session, so we don't have those muted the whole time. So please do stay muted until you're invited to speak. We also would like to invite everyone to load your full first and last name and your company affiliation into that Zoom window. So in the participants list, if you're able to rename your line there just to list your organization affiliation, that helps everybody kind of know who all's in the room and we can see who we all are. Just a reminder, we are recording the session and using the AI companion in Zoom to collect those notes. So we do record these and put them on the website. So if that is an issue for you, feel free to just stay on mute, but you're welcome to stay and watch the session. The recording and the notes for our last workshop are available on our website. So we'll talk a little bit more about that in our training series a little bit later. Finally, questions and discussion. So we do want to invite active participation. Certainly invite you to listen to all of the speakers as they are presenting, but also use that chat feature if you've got questions. We do have people kind of watching that, and we'll try to answer questions as best they can. Obviously, the panelists that's speaking won't be able to answer your questions directly until they're done, but they can also scroll back through and offer some responses when they are done presenting as well. Later in the session, when we do invite people to unmute and ask questions, we invite you to turn your camera on, introduce yourself, and then ask your question. And John McDonald will lead us through that time of question and answer. And then finally, there will be a survey. We would really appreciate your feedback and any ideas on future sessions. And so just please let us know your suggestions. Drop any suggestions for future workshops or training session ideas to that membership@dnp.org email. And finally, again, one more reminder, the webinar is being recorded. So as usual, before we start, we want to offer a couple of important disclaimers just to be aware of. So first and foremost, is that the following slides, right, our presenters don't necessarily represent the opinions of their organizations or the standards committees or users groups that those standards are affiliated with. So also remember that each of the standards that we're referencing in the presentations today are quite large, quite comprehensive, and so this is not intended to be a comprehensive review of each of those standards, and just be sure to refer back to the standards themselves for the authoritative content. Ron, can we pop those disclaimers up on the screen?
Yes, I'm sorry, James. Just running some things here in the background. There, sorry about that.
No problem. So there are those disclaimers are again, just for your review. If you have any questions, feel free to let us know in the chat. And then we'll go to the next slide just for our quick agenda for the session. So first, we're doing some introductions here now. We're going to hear some comments from our panel chair, John, followed by a brief presentation from each of our panelists. Following those presentations, our panel chair is going to spend some time in Q&A with the panelists, after which we're going to open the floor for questions from the audience in that last 30 minutes or so. So looking forward to a good, engaging session this afternoon. So with that, it is my pleasure to introduce Mr. John McDonald, founder and CEO of JDM Associates, LLC, a longtime friend of the DNP Users Group and our session chair for this afternoon. So, John, the floor is yours, sir.
Thank you, James. Thank you very much. Really excited about our workshop today. As James said, this is our third workshop, and the first two workshops have been very successful. both 90 minutes, lots of attendance, lots of interactive discussion. And the nice thing is they are recorded, as James said, so they're available to you on the DNP user group website. We try to cover very timely industry topics with each workshop, and I think that's why we get such good attendance and interaction. So I want to point out that just highlight the interaction part and just highlight what James said. Two ways to interact. One would be the chat feature with Zoom, and we'll be monitoring that. And you can type in comments and questions at any time. Okay. But for verbal questions, after each of the 5 panelists gives some go through their slides and give introductory remarks, we'll have a dialogue. I'll have a dialogue with the panelists, and then we'll open up for questions. And that's a good opportunity if you have verbal questions, unmute, and you can ask the question, have a live dialogue at that point. Okay. So today we're going to cover DR cybersecurity implications, as James said. We have 4 panelists. Ben Ealey with Epri, Grant Gilchrist with Tesco Automation, Robby Simpson with Enetrics, and Anthony Ciccozzi with Eaton. Okay. And so what I'd like to do is kick it off. And we'll start with introductory comments from Ben. And then after Ben, we'll go to Grant, Robby, Anthony, and then Ben will come back again with a summary. Okay, so Ben, why don't you go ahead, kick it off with introduction and industry context.
Sounds good. Thanks, John. So yeah, as John said, I'm going to start us off with some industry context just to help tee up the discussion that we're going to be having throughout all of our different panelists today. So to kick us off, that energy system is changing, and it is changing pretty quickly. We're seeing more and more distributed energy resources, whether that's solar, storage, or even electric vehicles. And it's really reshaping how the grid operates and communicates. And these resources aren't just add-ons like they've been on in the past. They're really becoming critical infrastructure. And as they move from a passive to more active role in grid operations, the reliability and the security of the communication interfaces isn't really optional anymore. It's pretty essential and core to its use. So cybersecurity has become a grid reliability issue. If attackers compromise DER communication systems, the consequences could include things like loss of visibility, grid instability, or even coordinated disruptions. And privacy is also part of it. DER communications often include information such as usage patterns or device behavior. And we have federal laws like the Privacy Act and the ECPA, even programs from DOE and FERC that aim to protect this data. But there are still gaps out there, especially as states like California introduce broader laws like the CCPA. And so the challenge comes that the protocols that we're relying on to reach these DERs, things like DNP, Modbus, or 2030.5, are the new attack surface. So what's the solution? We really have to take a layered approach. Security and privacy need to be addressed at every level, at the device, the protocol, the system architecture. It has to be tailored to the different risks and roles of each component and interface. But there's a lot of options out there, and that's what today's panel is going to be all about, exploring how cybersecurity considerations differ across protocols and why defining them outside of 1547 is both necessary and strategic. So to kick us off, I'm going to talk a little bit about the role that 1547 plays in this solution. This is a standard that's helped set DNP, SunSpec, Modbus, and 2030.5, the 3 protocols that will be covered in today's webcast, as the default interfaces for DER communications. So it's often looked to as a potential way to also achieve cybersecurity. But it's important to note that 1547 doesn't address cybersecurity or privacy, and that's a gap that we will need to fill through complementary efforts and requirements that you may need to specify. So let's talk a little bit more about that. So 1547 is the de facto standard for interconnecting DERs to the electric power system. It uses shall language and it sets requirements that are enforced through utility interconnection requirements. So essentially, in order to interconnect to the grid, utilities require compliance with 1547. So it covers everything from how DERs behave when voltage or frequency are outside of bounds. It defines grid supportive capabilities that these DERs must support, and otherwise sort of sets a default for DER behavior on the grid. And a key aspect of that is that in 2018, communication capabilities were also added to allow area EPS operators or others to update the different set points for grid supportive capabilities as the local grids changed over time. So it requires that 2030.5, SunSpec Modbus, or DNP be available at a local DER communication interface on that DER system. One important point, though, is that this particular standard does not cover the communication system or the local network gateway. And that was pretty intentional. It kept the focus on the interconnection requirements at the DER site, which allows companies, whether they're DER manufacturers or network providers, to really concentrate on the core capabilities that they know without being locked into any specific communication technology. It also gives flexibility to utilities to choose whatever network type and communication systems that they may want to use, and allows them to be replaced or updated without making the end device obsolete. So for DER manufacturers, this can be a big advantage because they can ship a common product that isn't prescriptive to a particular utility or region. So in short, 1547 sets the functional requirements for interconnection, but it leaves communication choices open. And this allows the utility to focus on the networks they want to use to reach grid edge DERs through gateway or even directly, and lets the customer adopt their own optimization and lower local level controls within the DER site through their plant controllers. So on this slide, I'll talk a little bit about some of the scope limits and what is going to make some of my fellow panelists here's presentation so important. So the first challenge we ran into when we're trying to capture cybersecurity requirements in 1547 is that these devices can last a long time. A DER that's installed today could be on the grid for 20 years or more, depending on how long they last. And that means that any requirements we set for grid functions, communications, or even cybersecurity have to hold up for decades if we're setting them through 1547. 1547 certainly can be revised to address these changes, but that does take time. If you look at IEEE 1547.2018, which is the latest version that's out today, the first products that were tested to conform with 1547 hit the market in 2024. So that was 6 years from when the standard was first published to when the first products hit the market. So the process doesn't move quickly, and existing DERs are often grandfathered in. So the tension there comes from the fact that cybersecurity can't sit still. Threats evolve, and locking security to any one standard for 20 years is pretty unrealistic. On the flip side, if we're making requirements that are too flexible, we end up with countless variations at the interface, which makes interoperability a complete nightmare, which is something else that 1547 has prioritized. So maybe to give a quick example, consider passwords. In the 1547 working group, we've reviewed many of the best practices set forth in cybersecurity best practices today. And one of those we reviewed was setting secure passwords. It's not necessarily a protocol level feature, but one that I think we could probably all relate to. So we can probably all agree, good, you want to have solid, secure passwords. But what we were finding is that even though everyone agreed with that in the group, defining what secure meant and how to implement that was difficult to really nail down. So we ended up with a really large number of options and no guarantee that any of them would survive that 20-year test. So in short, if the definition is too loose, it makes it hard to test. If it's too strict, it may not age well. So the big question is, how do we balance that need for decades-long stability for interoperability with the need for cybersecurity that can evolve organically? And what we had found is that it needs to be a bit of a layered approach. 1547 can only do so much. Utilities, manufacturers, and policymakers must create their own policies and practices that layer on top of 1547 to ensure systems stay secure. So a couple more challenges we ran into that I think are probably worth noting as we go into this discussion is testing adds another layer of complexity. So many of the current certification programs like those in 1547.1 or UL 1741SB are designed to verify functional compliance. So they're testing a representative unit, and then there's sort of an assumption that all deployed devices will behave the same as that representative unit. And we don't really go back and retest those unless there's a major hardware or software change that would justify that. But with cybersecurity, these practices tell us that vulnerabilities can change and emerge even without those changes, such as a major hardware or software change. So ongoing testing is important. And what this tells us is that cybersecurity guidance needs to live outside of 1547. Developing protocol-specific recommendations and layered strategies that address risks at the device, protocol, and system levels are all important. And that's where our next speakers are going to come in. They'll dive into how these considerations differ across protocols and why defining security at that level is both necessary as well as strategic. So on the next slide, I wanted to touch on, so how are the future versions of 1547 planning to address cybersecurity? There is a revision going on right now, and it's an active discussion. And the approach so far has been to avoid adding requirements that will prevent manufacturers from following future best practices. Instead, what we're doing is we're trying to enable capabilities without picking winners, meaning that we don't necessarily dictate which specific technologies or solutions may be used. We may specify capabilities like interfaces that are used to configure protocol parameters like the IP address or updating certificates, and specify that those must be behind some form of authentication, but leaving that form of authentication up to the industry to decide. We're also looking at setting defaults for protocols, but leave room for the area EPS operators and DER owners to apply alternate methods as they may be needed. And finally, we're looking at how gateways and related standards like 1547.10, which defines DER gateways, can play a role in addressing utility-specific cybersecurity needs. Utility-specified gateways, as we typically see in utility telemetry requirements, gives utilities some degree of flexibility while still ensuring that critical protections are in place where they matter the most. And this allows for utilities to add things like deep packet inspection, zero trust, or other cybersecurity mechanisms without having to convince every single customer to adapt to these. So for my last slide, I wanted to show an architectural diagram for DER integration. And this is a generic one. There's probably many variants that we could create and that you guys may be able to think of. But the reason we want to touch on this is it becomes important when discussing cybersecurity because where these protocols are used impacts the threats they're exposed to and how do we address it. So communications with utility-owned systems are often done using DNP or 61850. Utilities are already using these protocols for SCADA. So it's only natural that these systems connecting to their SCADA environments support those same set of protocols. In some cases, Modbus may be used locally at the DER site. When that happens, conversion is required through some degree of local DER gateway, or at least that's commonly what we see. And for DERs that are customer-owned and providing grid services or participating in energy markets, the communication paths can look a little different. If DERs are aggregated by a third party, utilities typically communicate directly with the aggregator using protocols like 2030.5, DNP, OpenADR, or OCPP. The aggregator then routes the appropriate messages to individual DER in the field using standardized or proprietary interfaces. And for other systems, the utility might communicate directly with an energy management system or a gateway that talks to DER components. This depends on how that system is set up and what interconnection agreements require these DERs to support. If the DER is part of a larger system, there's usually an energy management system coordinating all the subsystems to ensure that the entire DER system performs as expected. Utilities typically use 23.5 or DNP for this communication, while coordination of those individual resources happens over the protocols those subsystems may support. One place EPRI has seen IEEE 23.5 adopted is for small-scale DERs, where utilities want to use the internet for connectivity. 23.5 provides that end-to-end security that Robby will talk about later, and is well-suited for internet-based communications. In contrast, DNP tends to be more prevalent with those larger-scale systems, especially where today's telemetry-based requirements. But here's the bottom line. There really isn't a wrong way. There's many correct ways to do this, but each protocol's strengths make it more common in certain applications. And there's always going to be some degree of exceptions. So as we move forward, keep in mind each of these different pathways and some of the choices behind them, because they do have an impact on some of the cybersecurity considerations when you're building out an end-to-end system. So at that point, I'll hand it back to you, John.
All right, Ben, thank you. So Ben planted the seeds, for what we're going to talk about now. And what we want to do is go into each of the three protocols, and then Ben will come back for a summary. So first, we'll go to DNP3, or IEEE P1815.2 with Grant Gilchrist. Grant?
Hi, John. Hi there. Yeah, so we're talking about DNP3, which I assume, since we're on something sponsored by the DNP users group, most of you are familiar with. Can we get the next slide? So, history of the security features in DNP3 goes back quite a ways. We started with something that was called DNP3 Secure Authentication, which has become over the just recently the DNP security layer. But it's all started back in 2008 or even earlier. There was a version 2 that came out in 2008 as a DNP document. Then there was some review by the Information Trust Institute at the University of Illinois. And also, if some of you will remember, the NIST Smart Grid framework work that started in 2008 and got around to doing cybersecurity reviews in the 2011 timeframe. Through that time, DNP3 secure authentication continued, and with version 5 being the current version that's out there, published in 2012 as a part of IEEE 1815, which is the DNP, the IEEE standard for DNP. So that layer has always been based on doing message integrity and device authentication through message authentication codes, which are sort of like checksums on the end of messages. That version 5 added the ability to download keys. And now the DNP users group is currently working on well, actually it is basically finished, but being included in the current draft of 1815, which we hope will be released next year. It has been approved for going ahead. So that version will have encryption in it, as well as authentication and message integrity. Also, as part of DNP Cybersecurity version 6, we are adding a new protocol called Authorization Management Protocol. And it does a number of features that is not directly interfacing with the DNP3 stream, but is used for managing roles and keys and integrating the whole process with the utilities public key infrastructure. And of course, its most important job is authorization as opposed to authentication. So saying not just I am who I say I am, but also saying, are you or are you not allowed to access the network? All right, can we move ahead, please? So this is the architecture, and this is what makes DNP3, the DNP3 security, very different from some of the other possibilities that are being discussed today, in that it works just below the application layer at the session layer. So each of these boxes is a protocol stack. And you can see as we go from left to right, this is a typical SCADA type network where you have the controlling station on the left-hand side going through an IP-based network to either on the right-hand side, say a terminal server or a modem that speaks over either serial links or unencrypted radio. This is very typical kind of SCADA network that exists out there today in a lot of utilities. And as you can see from the diagram, if you're dealing, say, with IPsec, secure IP, that gives you security from network access point to network access point. So from that's the yellowish arrow at the bottom there, site-to-site security. And then above that, you may be using TLS, which is device-to-device security, but only from device to device, where as long as you have an IP network underneath you. So that's the more orangish arrow. So DNP3 security operates just below the application layer at the session layer and works end-to-end regardless of the fact of whether it's being carried over an IP-based network or a serial network or a radio network, and make sure that the security is applied in all of those cases. And this is consistent with DNP3's goal right from the beginning as being able to work over these kinds of networks. You can also see AMP there, which operates more or less at the same layers. It is an application layer all of its own, but is basically carried within the DNP3 security layer. And so if, Ron, if you just give me one click there on that slide, and you can see that the DNP security is carried through the network access points or routers, through the terminal servers or radio head end, and all the way from one end to the other, so that no matter at which point the network is accessed, there is always security, including authentication, encryption, and authorization. Next slide, please. So the features of DNP3 security, as I mentioned, it's at the session layer. It has used message authentication codes since its earliest version, and now optionally supports encryption. The newest version is defined as a separate layer. So it can actually be used for other protocols. So if they chose to use it, there would not be an awful lot of integration problems. The most recent version uses elliptic curve algorithms, so that's consistent with DNP's goals from day one to be able to minimize processing power and bandwidth. And the newest version simplifies the procedures of the protocol and uses new algorithms. AMP, which is the new addition to the suite, to the protocol suite here, is specifically for authorization. This is it works over the same kinds of networks as the DNP3 security layer, but it also manages keys, certificates, roles, and above all, authorization over those networks. So not just am I who I say I am, but also am I allowed to communicate? And what roles am I permitted to perform while I communicate? The key piece of both AMP and the DNP3 security layers is that unlike previous versions where keys could essentially be typed in by a human, these devices implementing these protocols generate their own keys and they don't show them to human beings. And then it's just a matter of AMP saying, yes, you device with those keys, you are allowed to talk to this device with these other keys. And we are also defining AMP so that it deals with redundant connections, redundant controlling stations, and redundant authorities. And it also, because it is not IP-based, it means that we can actually limit communications to just these protocols, and we don't have to worry about all sorts of firewalls and rules in order to prevent other protocols and other attackers coming in. Next page.
You're right there.
Okay, so the relationship of DNP3 security to standards is that there is an IEC standard, IEC 62351 Part 5.
Good. Just trying to stop a Zoom meeting that
Hi,
I'm in that's
Joshua.
giving
Could
me.
you please mute yourself? Thank you. All right.
Just got it.
Okay. So the IEC 62351 Part 5 defines the generic version of the DNP security layer which is used not only by DNP3, but by IEC 6870-5, which has always been DNP3's kind of European and the rest of the world cousin. And so that's the relationship to those IEC standards. Then DNP3's secure authentication became DNP3 security layer as a part of the IEEE 1815 standard. Externally to the IEEE standards right now is the DNP secure authentication test procedures, which are for securing SAV5. And we're working, as of the next year, we'll be working on developing test procedures also for the new SAV6 or security layer. That's what we're now calling it. Next page, please. Testing and certification. Everybody's going to be talking about this. DNP users group has been doing certification for decades now, and we are going to be including that in security in the testing conformance certification program. At the moment, SAV5 is not part of the certification program, but we do have conformance test procedures available for it so that people who want to test for it can test for it. Development starts next year for the DNP3 security layer and for AMP on developing test procedures for those. The testing program that is managed by the DNP users group right now is specifically for the non-secured version of DNP3, but I highly recommend anybody who's going to get the security tested on their system to also test the DNP functionality. We are expecting in the fall of 2028, as a part of a major project that's starting this year, we will have an interoperability demo for the security layer and for AMP. Next page, please. So we've been asked to highlight the top 5 strengths of these protocols. Absolute top in this top strength of this protocol is that the data stream can be secured not over IP net, also over serial networks and any mixture of those. Ron, I think you can tap that one more time and it will draw a line. Yep, there we go. So that is the key piece of key strength of this protocol. Also, it does enforce role-based access at the device level, and eventually with AMP, we'll be able to assign roles remotely. It does provide monitoring suspicious events. So because this is a SCADA protocol, we can actually use SCADA to keep track of the security. So we have SCADA statistics points, which will serve as a bit of a primitive intrusion detection system, at very least a monitoring system by which you might be able to identify security intrusions by monitoring these statistics. These protocols can be used not only by DNP3, but also by other protocols, and is basically going to include its own PKI that is specific to SCADA networks that is called AMP, that will again work over both the IP and serial networks. And that's it for me. Thanks.
All right, Grant, thank you. So we've Grant covered DNP. Now we'll move to the second protocol, IEEE Standard 2030.5 with Robby Simpson. Robby?
Thanks, John. Hi, everyone. Robby Simpson. I'm a principal and co-founder of Enetrics, where we make software for testing compliance to various DER standards like the ones you're hearing about today. I'm also the chair of IEEE 2030.5 and vice chair of 2030.5.1 and involved in a lot of other standards. Next slide. So a little bit about the background of cybersecurity for IEEE 2030.5. So first off, cybersecurity is a normative or required part of 2030.5 and has been since day one. The initial publication was back in 2013. So since that time, we've always had cybersecurity as a required element of 2030.5. Also, we've maintained backward compatibility and interoperability since from the beginning as well, showing that it can be done, which is important because, as Ben mentioned, a lot of these devices are going to be out there for quite a while. So it's important to maintain not only that security posture, but be able to maintain your backward compatibility. Um, the cybersecurity aspects of 2030.5 are designed using widely adopted technologies, the same as all the components of 2030.5. If you were in the last workshop, you probably heard me say that the unofficial motto, if you will, of the 2030.5 working group was "Don't be weird," and what we meant by that was, don't invent anything new if you can help it. Especially when it comes to cybersecurity, because there's a lot of good learning already out there, and as smart as the folks are on the 2030.5 in the 2030.5 working group, there's a lot of more smart folks. It's a larger population out there when it comes to the entire internet community. These technologies are used in a way that also simultaneously require little to no user intervention, which is very important for a standard like 2030.5, where you're often dealing with consumers and consumer firewalls. If you have to tell a residential solar installer how to bypass the customer's firewall, you're probably already going to fail. It's also targeted to be, cross-domain, because you're going from, say, consumer-owned equipment to, say, the utility server, and it's meant to be consumer-facing. And then lastly, like Grant mentioned with DNP, we put a lot of work into making sure that we targeted the constraints of embedded systems, devices that have very little RAM, very little flash, very little processing capabilities. The 2030.5 cybersecurity elements went through multiple independent third-party cybersecurity audits, which we're quite proud of, and we've had no known issues since the initial publication. But of course, we stand ready to address them, because that's just the way of the world. At some point, I'm sure it will happen to everyone, right? And then it addresses a variety of international and regional requirements and guidelines, and we have to stay on top of those to make sure we continue to comply. And lastly, I should note that 2030.5 is very much focused purely on the protocol cybersecurity. That's our scope, if you will. So things like physical security, TPMs, these sorts of things, they're out of scope for 2030.5. But certainly, if you're building a device that uses 2030.5, are things to consider. On the next slide, I highlight some of the components, if you will, of 2030.5 cybersecurity. So it uses TLS 1.2 in a mutual fashion. And what I mean by that is that both ends of the communication have certificates. And so this TLS protocol is the same one you all know and love from, say, online banking and all your other internet experiences. The MTI cipher suite, mandatory to implement, is there. I won't read it all out to you, and it has a very specific elliptic curve. Why is that important? That's how you get interoperability. If you have a mandatory to implement cipher suite, then you know that all the devices can all speak the same language, if you will. It doesn't mean you can't do additional cipher suites as well, but this means there's always one to fall back on for interoperability purposes. Some other components, we have something called an LFDI and an SFDI, a long form device identifier and a short form device identifier. Those are essentially different sized hashes of a device's certificate. And those are used for identification purposes. And the reason that's important is in a normal internet world, if you open up the certificate, there's a DNS name in there, right? If you're Google's certificate, it'll be inside the certificate, cryptographically signed, google.com. Well, with devices like the DER that we're dealing with 2030.5, they're not going to have a DNS name, and they probably aren't going to have a static IP address either. So you need a way of tying an identity to that certificate. And that's where these LFDIs and SFDIs come in handy. So when you go to, say, register a device with a utility, you can give them that LFDI, and that ties it in a secure fashion back to the certificate because it's a secure hash. Likewise, there's a PIN to make it consumer friendly because consumers don't necessarily want to be typing in these big, long LFDIs. So the PIN is kind of a short version, and it's a way to say, not only am I talking to a server that has a valid certificate, I'm talking to the one I want to talk to because it knows my PIN. And the consumer doesn't have to do that. It's the device does it. And then there's also firmware and software and security update capability built into the protocol. There's the grouping mechanism, and this is important. So in 2030.5, the devices can be assigned to groups, and often those groups for utility are based on the electrical network, right? What feeder are you on? What transformer, et cetera. But you don't want to expose that to the consumer for privacy reasons and grid security reasons. And I have a lot of stories about what can go wrong if those get exposed. But the bottom line is 2030.5 allows the grouping of devices by those types of features. But from the consumer's perspective or from the consumer's device's perspective, it just knows it's in a group. It doesn't know why it's in that group. It doesn't know who else is in that group, et cetera, et cetera. And then there's an access control example provided in the standard as well, but not mandated. For a variety of reasons in 2030.5, we chose not to mandate a specific form of access control, but we did provide an example if folks want to follow it. So the next slide, I'm going to dive in a little bit more into those certificates or those credentials. So there's a PKI, public key infrastructure capability that's defined in the standard, where you have CERCAs, MCAs, and MICAs. Those are different levels of certificate authorities, the root certificate authority, a manufacturer, et cetera. You may have one of those, you may have all of those. And the certificate format is specifically defined. It's a specific type of X509 certificate. Once again, we really want to lock those aspects down, not just for security, but for interoperability. But 2030.5 does not define any of the business aspects. It doesn't say who is the root of the PKI, who's going to run the root, or who's going to run the PKI, et cetera. Because, different use cases and different regions and different manufacturers all have different business needs and reasons for the way they want to do that. So some examples, there's national PKIs that have been set up. For instance, they're working on one in Australia. Often utilities act as the PKI, the root of the PKI. Sometimes the vendor issues certificates for their own devices. There may be consortium, and there's even interesting cases where they can be dynamically negotiated between devices. And all of these are possible, and you can even do several at once, right? There's never going to be one PKI to rule the world, in my opinion, because it's a business aspect. The credentials and the way they're used in 2030.5 follows the guidance of another IEEE standard, 802.1AR. If you're familiar with the 802 space, or if you're not familiar, those are the same folks that do Ethernet and Wi-Fi and all of these very popular standards. And so we followed the guidance on how certificates work for those kind of more consumer-focused and enterprise-focused devices. The certificates do not expire and they're not revoked, which I know is atypical if you come from a normal internet security world. But if you look at 802.1AR and other kind of IoT geared cybersecurity standards, that's quite common because you don't have a guarantee of connectivity to, say, a revocation server or to an OCSP server or something like that, where you can check to see if a certificate's been revoked, and if one expires, where you can get a new one, et cetera. So for those kind of machine-to-machine embedded, not necessarily connected reasons, that's not something that's required by 2030.5. Next slide. So some of the near-term plans for the 2030.5 family are on the next slide. I'll give that a second to update. There we go. So first off, everyone should be aware there's a lot of activity going on, not just for the base 2030.5 standard itself, but there's also, for instance, a family of profiles that are being defined under the 2030.5 heading. The first being 2030.5.1, which is a standardization of the common smart inverter profile. That's just a way of saying, here's how you use 2030.5 for the specific use case of, in this instance, utilities communicating to aggregators and utilities communicating to DER. So it uses the pieces of 2030.5 for that use case. There's a lot of test and certification improvements going on right now. And there's regional extensions happening. 2030.5 has been adopted, for instance, nationally in Australia. They have something called CSIP Oz, CSIP Australia, which defines exactly how they use it in Australia, that's built on top of that existing CSIP. And then there's also from a cybersecurity perspective, the continuous analysis of the landscape, right? Do we need to change something? Do we need to do something additionally? Some of the things we see kind of on the horizon, eventually, I'm sure we're going to have to tackle quantum resistant cryptography. Once again, I doubt 2030.5 is going to invent that. I think we're probably going to rely on the guidance of the TLS folks and what ciphers they put forward there. And then similarly, there's a lot of good work that comes out of, for instance, NIST with the SP800 series, and on and on. We could spend a whole webinar, I'm sure, talking about all the good guidance that's out there. But the bottom line is, I encourage you all to join the 2030.5 working group and help shape that future. And then next slide, a little bit more on test and certification for 2030.5. First off, I'll say stay tuned. I'm not ready to make any announcements right now, but there's some new developments in the works that I think you'll find very interesting and helpful in this space. But in addition, because we follow that, quote unquote, don't be weird model, there's a lot of good off the shelf things that are available today for testing TLS implementations, the use of, what effectively, if you really think about it with 2030.5, it's just a RESTful API, right? And so there's a lot of good off-the-shelf things for that, including penetration testing, et cetera. The nationally recognized test laboratories, NERDLs, have certification programs for 2030.5. And in Australia, they're also transitioning to a new certification program run by the Australian National University. So there's quite a lot of good activities going on in the test and certification space for 2030.5, and even specifically for 2030.5 cybersecurity. And there's a lot more in the works that I'm looking forward to. And then the final slide I have are just the top 5 strengths. As Grant mentioned, each of us put forward, what we consider are the top 5 strengths of our respective protocols. For 2030.5, I think the fact that cybersecurity is required by the standard is a strength. I think the fact that it's internet native, it uses those common internet protocols, and it's designed from day one to work over a harsh environment like the internet. It also utilizes well-known protocols and technologies, so you can easily grab folks from other industries, folks straight out of school, et cetera, and they won't say, what is this? They'll say, oh yeah, it's just another RESTful API. Maintaining backward compatibility. I'm covered in scars from having held the line along with many others in the working group to make sure that that's happened. But that's massive, because then you're able to not strand assets. You're able to give consumers and utilities and OEMs confidence that the standard will be continued to use in the future. I mean, we all know, like Wi-Fi, for instance, it's constantly being updated, but all the Wi-Fi devices work all the way back to that original 802.11b, and so that's a huge strength and why these standards get the popularity that they do. And then lastly, another strength is the little to no user intervention. When you're targeting consumers, residential consumers, CNI, and that's not to say it can't be used by larger systems, et cetera. But when one of your use cases are your average Joe, if you will, you want there to have to be little to no user intervention to get this all to work, and a lot of effort went into that. So that's the end of my slides, and thank you for your time. I look forward to questions.
Thanks, Robby. Okay, so we started with Ben, gave a good introduction to kick things off. Grant talked about the DNP3. Robby just talked about the IEEE Standard 2030.5. And now the third protocol we want to talk about is SunSpec Modbus. And Anthony now will talk about that. Anthony?
Thank you. No, I was just saying, I've been working in industrial control systems, cybersecurity, and power systems for 25 odd years, and Modbus is kind of the mechanical key of if there, use a rough analogy of protocols. It's been around since 1979, I think, and it's evolved from there. It's kind of a base skill set for anybody in control or automation. When it was developed, security really wasn't much of a thought. Networks are very isolated. Then over time, they start to get a little more interconnected. And, even when networks were connected, like on a plant floor or in a power system, nobody really thought that those things were hackable. Well, over time, you had Stuxnet. There was a test at Idaho National Labs. You were a generator test where they got a generator basically to continuously close out a sink and destroy itself. A couple 60-minute stories, and all this awareness gets raised, and then you have the creation of cybersecurity standards, and there you have Modbus, a protocol with no real inherent security capability. To secure a Modbus in the context of a network, it requires a lot of external devices, firewalls, network isolation, other controls in the network. Over the years, some firewalls are very control system specific firewalls were developed. Even Cisco and some of their firewalls and intrusion detection systems have very specific Modbus carve-outs where you can get very granular restrictions of Modbus commands, but there's really nothing inherent to the protocol itself. And now that you have a lot of these DERs being integrated in systems that are cloud-based in some extent, you have about as broad an entry point as you can, or a broad an attack surface as you can, as actors could potentially come in through an external interface through the cloud and then pivot through a network. So, to be adopted as a standard, Modbus security needs to be addressed, and to do that, as we've kind of heard with a little bit with DNP3, but probably a little more with 2030.5, kind of basing this using TLS. They're basing that a lot with the IEEE 62443 standards. And there is a Modbus security spec in development now at SunSpec, where they're going to start to embed some controls, remove those from relying on external design or external devices, and kind of embed some of that into the protocol itself. Next slide, please. Thank you. So some of the features of Modbus security, again, using mutual client-server TLS authentication, certificate-based identity, and certificate-based authorization, using some extensions in the certificates, similar to what's done in 2030.5. Leaving the authorization still to be product-specific. And then for SunSpec, so SunSpec does a very good job providing device information and profiles. There's mappings for that even to IEEE 1547. And they're really looking to complement that. IEEE 1547 kind of punted on security. I forget the exact wording in there, but they basically use some general wording, no matter what you use, you shall be secure kind of thing. So they really tried to address that here by through the use of certificates and cryptography to embed some role-based access controls. Next slide, please. So there are some Cypher suites being considered. The Internet Assigned Numbers Authority They basically maintain a registry of protocols, and they assign an acronym for the different cipher suites. There's an option for TLS 1.3. TLS 1.2 is currently widely adopted, so there is some room to grow there. The one thing about cipher suites over time, that they become obsolete. They become less secure. Just kind of it's just kind of how these goes. But there is an option there's the availability to grow more as 1.3 gains more adoption. Again, we talked about the authorization roles, basically enforcing those within the certificates. A lot of that was taken from like standards like 62351. In 62351, those are kind of your standard, especially when you deal more with maybe utility grade devices, kind of your view operator, engineer, administrator, installer type of roles you have in devices. Those are very common for customers to see and use. I think especially when you're in more like again, in utility, or you're governed by NERC CIP, those tend to be a little more standard. And the use cases, like I said, Modbus is very it's very widely adopted globally. Many people understand it. Many products support it. Many of the DERs you see out there, that's kind of their default interface right now, is a SunSpec Modbus interface. And some of the use cases you can see here, they kind of range all the way up from utility control all the way down to kind of homeowner DER access. I think it was mentioned by Robby earlier when you said, hey, you can't expect an installer to know how to maybe configure a firewall. And that is true. You want these devices to be very easy to deploy and very easy to integrate. However, you also need them to be secure, and your security requirements do change based on the type of system you have. So certainly if you're a homeowner, and you're connecting a few devices at your home, your security profile is much different than kind of utility scale DER integration. Or if you have some clusters of DERs you're aggregating, your potential for a larger grid disruption do increase. So the security needs to be very versatile. And I think what they're doing with the specification right now is, again, trying to pull in some of that, embed some of that security into the product or into the protocol itself. Next slide, please. Okay, some of the standards and activities groups that are kind of driving some of this. Again, we see the IEC 62443. It's kind of the IEC network standard. IEC 62443-4. You start to get more into like the local networks and devices. IEC 62351. We talked about some of the role-based information they're pulling in. There is some just kind of a native Modbus security standard work there. And again, we mentioned the SunSpec Modbus security working group. And as always, we just talked briefly about some of the cyber attacks and incidents that have happened from over time. And, at least as it goes in the North American grid, if there's some type of incident or attack, FERC will get involved. That'll manifest itself into some NERC requirements. Then you have other agencies like CISA here in the U.S. And you never know how that's going to change. So when you look at some of the things they're doing with PKI, with some of the certificate-based controls, or even kind of embedding birth certificates into these devices, basically authenticate or trying to find a cryptographic root of identity in these devices. A lot of that has stemmed over time from the evolution of these standards and things like in NERC CIP requiring more cryptographic identity to be embedded in. I think that's where a lot of the work is headed with Modbus. Next slide, please. Yeah, in terms of testing and certification, certification suites are available, and a program is available via SunSpec Modbus now. And again, TLS 1.2, I think the security for that is fairly well defined. You have resources like, the NIST SP 800 standards. You also have other standards out there. We talked about IEC IEEE 62351. UL has a standard 2900, and there's a suite there. Again, in the IEC standards. Something that may be limiting for Modbus is kind of the complexity of, the need for role-based access control and PKI in general, having that infrastructure in place. Again, that is a cost, but as the need for, again, we talk about these birth certificates and integrity checking, like in NERC CIP 10, they require a little more in-depth, for grid scale deployment of these DERs, they require a little more rigor in terms of, the integrity checking, basically ensuring these devices are what they say they are, running software that, is from the vendor. So there's going to be a growing need for that. Next slide, please. The top 5 strengths, kind of adding security to Modbus and, adding it now, with TLS 1.2 and TLS 1.3 out there, it does enable you to use modern cryptographic support, improved authorization mechanisms, again, embedding a role-based access control kind of into the protocol, into the process. Really, instead of improved, it's really it was non-existent in the past. Again, flexibility and integration. There is a wide range of cryptographic algorithms that will be supported for a while. And again, the global adoption. I mean, everybody's used Modbus at some point. You'll have an electrical installer. You may even have an electrician. I've seen electricians when we've gone on microgrid and DR integrations, kind of working around the interface and troubleshooting, all the way up through utility grade deployment of these DERs. So Modbus is a very versatile protocol, and again, depending on your specific network, your specific security needs, the embedded security will help a lot. And I think it will help the interoperability of the DERs among the vendors. So next slide, please. Oops.
All right, Anthony, thank you very much. Okay. We've gone through introduction and the 3 protocols. Let's have a wrap up now, a summary, and Ben will come back to do that. Ben?
Good. Thanks, John. Yeah, so as John mentioned earlier, we were talking about the security capabilities of each of the 3 protocols that are currently referenced in 1547/2018. And in the last workshop, we focused on the role that each protocol plays. So where we see them implemented in the field and the strengths they bring to the table. And today we did add a new dimension to it, which is around cybersecurity. So we took a deeper dive into each of how these protocols support security and what that means for grid operations. And so to wrap it up, I have two slides, and I'll summarize some of the key strengths of each protocol that the presenters have provided, and then talk about some of the architectural considerations. Essentially, where do these protocols fit and why do they matter? So first, let's look at the strengths. So first, to compare the top strengths of the 3 protocols, we've got DNP 23.5 and SunSpec Modbus. So first for DNP, today we heard from Grant. So he'd mentioned that DNP stands out because it provides end-to-end security across both IP and legacy serial networks. And this is pretty critical for utilities operating with mixed infrastructure, modern as well as legacy systems. At the device level, DNP enforces role-based access control, reducing the risk of unauthorized commands in environments where multiple entities interact. It also includes built-in SCADA statistics points, which allow operators to monitor for suspicious events and detect anomalies, which is a pretty practical feature for utilities that already rely on SCADA for visibility. Beyond that, DNP offers extensible security layers, meaning that other protocols can leverage DNP Cybersecurity version 6 through DNP-SL and AMP. And looking ahead, AMP will enable certificate-based key management and authorization across both IP and serial connections, which will align with many of the modern PKI practices. So the key takeaway from this one was, for me, was DNP is particularly strong in operational control environments, especially where legacy systems and mixed networks are involved. So next, 2030.5. For the key strengths, we heard from Robby. So 2030.5 takes a different approach by requiring cybersecurity from day one. Security isn't bolted on like it is on some of the other protocols. It's really baked into the standard, which simplifies compliance and reduces variability, because to implement 2030.5, you have to implement the cybersecurity capabilities of that protocol. It's also internet native, designed for IP-based environments and consumer-facing applications, making it ideal for DERs that interact with cloud services or aggregators. It's built on widely adopted internet and IoT technologies, which can make it easy for vendors and developers to implement it in a secure fashion. It also maintains backwards compatibility while evolving security features, proving that security and interoperability can coexist, which are very important today with the number of DERs that are appearing on the grid. Another advantage is minimal user intervention. The protocol works even behind things like customer firewalls with little configuration, which is crucial for residential DER deployments where technical expertise is limited. And the key takeaway is 2030.5 is future-proof protocol for distributed internet-connected DER ecosystems. And it seems like they've succeeded in not being weird. And then lastly, SunSpec Modbus. Today we heard from Anthony. So SunSpec Modbus recently announced new profiles for cybersecurity, bringing modern cryptographic support to widely used legacy protocol. It ensures encryption and efficiency, addressing vulnerabilities in older Modbus implementations. It also improves authorization by implementing role-based access control with standardized roles for common use cases, supporting granular control for utilities, aggregators, as well as homeowners. Flexibility is another strength. SunSpec Modbus offers multiple cipher suites and advanced authentication modes, making it adaptable to different security needs and environments. Its global adoption ensures that there's compatibility across platforms and devices, which is essential for interoperability in diverse DER ecosystems. And then finally, its foundation for TLS 1.3 positions it for future cryptographic advancements, showing a commitment to evolving security standards that are out there. And the key takeaway I took away from this one was that SunSpec Modbus is catching up with some of the others, bringing some of the modern security to a protocol that the industry has relied on for quite a while now. So on the next slide, let's revisit our architectural diagram. So as I was talking about earlier, managing DER systems involves a lot of different actors. Coordination has to happen from the energy markets all the way down to those individual components of a DER system. And a key challenge is that this ecosystem uses roughly 20 different protocols that are out there. So which protocol is used depends on the technology type, where the interaction occurs, and the architecture and the kinds of programs or services being provided. Today, we focused on the 1547 protocols, so anything that would be export capable, DER controlled through that local communication interface. Now, depending on the architecture and who owns the DER, these protocols can be deployed in a few different ways. Typically, protocols like 2030.5 or DNP are used over utility networks. These have the security and the capabilities that make them good candidates for the longer hop back home and from local site back to the utility enterprise. In some cases, utilities also deploy DER gateways. Gateways provide segmentation and allow utilities to add site-specific functionality, perform things like protocol translation, and enforce cybersecurity policies. When gateways are used, a different set of protocols often come into play. For example, SunSpec Modbus is pretty popular for small-scale DERs. So it's common for Modbus to be the protocol at the DER's local interface. So that E and F here on this diagram. And then that traffic is converted to something like DNP or 2030.5 or some other protocol for that hop back to the utilities DERMS. So I've been mostly focusing on utility pathways to local interface, but utilities aren't the only ones communicating with DERs, and that should also be acknowledged. Aggregators and virtual power plant providers also play a pretty big role. They often use the same pathways to access DERs. So now that we reminded ourselves where these protocols are typically used, let's talk a little bit about how this impacts cybersecurity considerations. Gateways can be inserted at any point in these pathways. They provide segmentation between utility networks and customer networks, which can be a good thing, but there is a challenge. Customers making purchasing decisions for DERs And so for protocols with optional cybersecurity like DNP and Modbus, the choice to implement security is somewhat up to them. So if a system doesn't support the specific security capabilities that a utility wants, gateways or network adapters may be needed to bridge that gap. This also brings us to how security is addressed in 1547 revisions. Standards sets today, the latest revisions show that it sets a default approach, but others can be used if there's mutual agreement between the utility and the DER owner. So the flexibility is important, but it also means the industry needs to plan ahead because new DERs are installed every day. A couple other things that have come out of the 1547 working groups that I wanted to acknowledge before we wrap up. First, the industry needs to understand the realities of certificate management, as each protocol has their own ways of implementing it. And Robby alluded to there being multiple ways to implement certificates earlier in this presentation. So things that you would want to understand are how PKIs work, and make sure you're having those internal discussions about whether certificates will come from the manufacturer, third parties, utility, or some other provider. Certificates really need to be deployed when the DER is interconnected. So you need to have your ducks in a row early and kind of have a plan. If you're using Modbus, evaluate compensating controls or physical access restrictions if cybersecurity profiles are not used. And be aware that 1547 subgroup has discussed that it's nearly impossible to guarantee that Modbus TCP wouldn't be exposed to the public internet. There really aren't any requirements that the customer and the utility, the interfaces for customer traffic as well as utility traffic don't necessarily have to be isolated. And it's often the same interface is used for both, at least in smaller scale DERs. And then for DNP, there are multiple correct approaches. Many utilities are using VPNs and TLS today, but the newer SAV5 and SAV6 profiles offer some additional benefits, but they will require that DER system owners implement those capabilities since they do have to be specified separately. So bottom line, each protocol has strengths and trade-offs. Utilities and the industry should understand these differences and make some informed decisions during the interconnection and the building process. And that's how we ensure that security happens without slowing down the whole process of DER integration. So thanks, everybody. I'll pass it back to you, John.
Thanks, Ben. Fantastic summary. Really appreciate that. Looking at the time now, we were going to have I was going to have a dialogue with the panelists, but I think because of time, and also we want to make sure each of you have a chance to ask questions of the panelists. We'll move. What we'll do is we'll move right into audience engagement Q&A until we get close to the hour, top of the hour, and then James and I will have final comments and we'll close. But then, if any of you have additional time, we will all stay online for another half hour for informal discussion, because we in the two previous workshops we had so much interaction and questions that we just ran out of time, and we had requests that could we be available for additional time? So we want to do that today. So what we'll do now is we'll move to audience Q&A. You've used the chat quite a bit through the workshop to ask questions, and you continue to do that, but also we really welcome unmute yourself and you can ask a question for all the panelists or some of the panelists, and we would like to open that now. Okay, so feel free to do that right now. Anybody have any questions or comments?
Hey, John, question to Robby. He mentioned in one of his slides that IEEE 2030.5 is mutual authentication. If you go back to the previous slide, which has like 6 rows, the first one looks like point-to-point, which makes sense for mutual authentication. Can Robby comment, how does mutual authentication play in other scenarios? I mean, how does that point-to-point, especially with gateways, the meters, other things will help for that? How does the mutual authentication is implemented with so many different hops?
Robby?
Sure, great question. Can we go back to the architecture slide? I think that was the one. It's like two back. This one, yeah. So great question. So with 2030.5, our goal is end-to-end security, right? So depending on what the endpoints of the communication are, is where the authentication occurs. So, just using these as an example, if you're using communication path A, one end would be the utility, the other end would be the DER, and so both of those sides would have certificates, and you would do mutual authentication between them. Similarly, if you were, say, using a gateway type of scenario with, like, I think interface C, it's really the gateway itself breaks that end-to-end security, of course. And you may very well even be translating, very likely, I would say, be translating protocols, because that's often the point of a gateway. So at that point, depending on which side, C or F, is where your mutual authentication would occur. It's really whichever two endpoints are communicating with 2030.5 are the two endpoints that are authenticating one another. And 2030.5 really can't make any guarantees beyond that when it translates to other protocols, by the very definition. Thanks.
Thanks,
Thank you,
Robby.
Robby. Yeah. And follow-up question, Robby. I mean, the certificates are unexpired. I mean, do you think that's a good practice? I mean, 20, 30 or unlimited. What if a certificate is compromised or one of the chain is compromised? I mean, is there any option to replace the compromised certificate, or is it just replace the device?
So good question. So of course, replacing a certificate depends on how it was manufactured and what's available there. 2030.5 does have an inbuilt software update mechanism where you can indicate in a standardized fashion that you want to update security credentials. So, if a manufacturer were to implement that in a 2030.5 device, that's one way you could do it. But it really, it depends on, it's kind of like firmware updates, et cetera. Like, do folks allow it? How built in is it, et cetera? But to the point of, it's based on certificates that do not expire. That's based on the guidance that effectively you cannot count on these devices having any kind of connectivity. And so if you can't count on them having connectivity, you can't count on them being able to definitely update their credentials, right? So it'd be awful if someone, say, bought a DER, put it on their house, and it wasn't connected, and all of a sudden it quit working just because the certificate expired and it had no way of updating that certificate. But that's not to say that, if the root is compromised, heaven forbid, or if particular credentials are compromised, et cetera, you can certainly, do access control mechanisms to no longer authorize that device for things. So you can have deny lists, you can have all sorts of access control mechanisms to avoid using that again. And of course, you could, in theory, reflash the device. But the 2030.5 concept kind of goes back to that 8021AR, where they're almost viewed as birth certificates. And if you're going to put a new certificate in there, it's effectively kind of a new device. You can think of it that way.
Got it. Thank you, Robby.
Thank you.
As I should point out that as part of developing AMP, we are looking towards that ability to be able to update certificates remotely, and not just over IP networks. As far as the actual getting certificates there, most IP networks, there are various different types of PKI protocols that can be used. most of them operate over IP. AMP will be one that is going to operate over the same networks as DNP. But Robby makes a good point that, you know, you have to allow for the fact that certificates are going to need to be updated. Usually, as long as you are not updating the actual root certificate or the center of trust certificate, then downloading a certificate is an okay thing to do. Anyway, hopefully that provides a little extra information.
That makes sense, Grant. Thank you.
Okay. Any other questions or comments?
Yes, so this is George Cao, and with Schneider Electric, just a follow-up question regarding the PKI and also the certificates, as Robby and Grant has mentioned. So if referring to that architecture diagram, there could be multiple vendors playing in this market, and then they have to talk to each other using a secure certificate, whether that it's DNP3 or 2030.5 or secure Modbus. Does that mean the PKI, especially as Grant mentioned, the root certificate has to be somehow unified? Because otherwise, if that is a free market, then anyone can be a root certificate, and then those devices usually come with a limited secure storage space. So just wondering if the panel has some comment about could be some potential challenges, or if the standards is already starting addressing those issues.
I'll take a stab from a 2030.5 perspective. So, you know, this is one of those tricky areas where it starts to touch on business, right? Or who runs the PKI, et cetera. And I think, you know, from a OEM perspective, on the one hand, you would think, you know, the less roots, the better, because that's less root certs you need to have pre-installed in a device to ensure interoperability. But then on the other hand, from that same OEM's perspective, you may not, you know, necessarily want to get into business with one of the roots. It's, you know, on and on and on. You know, unfortunately, I think this is a common problem, not just in the PKI for the grid or for DERs, but even on the internet, et cetera. This is just an issue of when you have commercial PKIs, it is difficult to coalesce around a handful of roots, or at least around one. Sometimes you can have that handful. We are in the 2030.5 space. There are folks that are using kind of more dynamically generated certificates. And that was something that was in one of the original drafts of 2030.5 that we didn't standardize at the time, but you can kind of think of like an OAuth type scenario where you can really negotiate certificates on the fly. And that's another mechanism so that you don't necessarily have to carry a large number of root keys. But yeah, this is just unfortunately one of those areas where, you know, business and what looks the best technically don't always match up.
Understood. Thank you, Robby.
The philosophy that we're taking in the development of AMP, and we've all spent about at least a year anyway talking about these scenarios, is that you have to allow for the idea that the device has its own certificate, and it may not have the root as the network that it wants to join. So there has to be a couple of things. One is that you have to have the ability to get the root certificate in there, at least one of them, and that you're going to use in your network. The second thing would be a sort of a registration a registration step in which you could take the public key out of that device's certificate and say, by the way, I'm putting this device in my warehouse and it may be installed in my network at some time, and it's going to have the following public key. And so that way, when it does join the network, the authority can recognize it when it comes up and says, hey, this is my public key, and And then therefore the authority can give them and say, okay, I understand that that's your certificate, but this is your new certificate. So there's a couple of stages there that would have to take place.
Got you. The certificate signing services or
Something like,
something
yes,
similar.
basically like that, yes.
This comes into where some of these trade-offs are, what market you're in. If you're designing a controller, let's say, you typically want to give the end customer the flexibility to install their own certificates on that device. You may have some that help you with secure boot and some other things, but like when you talk about like communication security, you want the ability to have the user to maybe install their own. Maybe not all products. Certainly if you have a residential product or something, there be some different considerations there. Many utilities want to install their own, so it's just a balance. It is a very difficult thing because you don't really have. I think Robby mentioned Australia is kind of maybe standing up its own kind of national PKI. I don't think you'll ever see that here. Companies talk about that. What do you want to do? What happens when your certificates expire? What happens if somebody gets caught? So that it's very complicated. So it's just the best you can, allow users to have the configurability or, for your market, figure out what's best.
There's even manufacturers who've stood up their own PKIs, especially for DERs, since your certificates need to be implemented when that system is interconnected, regardless whether you're communicating with it or not. And since you usually have to get the manufacturer involved to make any changes to those certificates, that's one of the reasons we often recommend to utilities, if they're planning on talking with devices and certificates are required, go ahead and figure out what that architecture is going to be now, because it can be difficult to go back and change it to thousands of devices in the field afterwards.
Oh, yes.
Yeah. It's one thing when it's a utility-owned device. It's another thing when it's a customer's DER.
Thank you for that.
So we want to follow our schedule. We appreciate your time. We want to be on time with our schedule. But as we said, once we close, we will stay online for any of you that have some additional time and want for some additional questions, comments, discussion with the panelists. So now I'd like to do a brief close, then I'll turn it over to James for a close, and then we'll be online. So I want to, first of all, this is very, very rich in technical content and very educational for everybody. The workshops that the DNP user group does is our third one, open to the public at no cost. So it's a fantastic opportunity to really hear from industry experts on topics that are very timely and very important to all of us. So I want to, first of all, help me thank the panelists today for, all of their experience, their knowledge, their background, and helping all of us learn more and hopefully helping all of us do a better job with the work we're doing in our companies. So thank you, panelists. I want to thank the panelists today. And follow the DNP user group, the website, the emails, the announcements that we make. And I want to thank everybody. And let me, as the moderator, I'll turn it over to James for your final closing. James?
Wonderful. Thank you so much, John. Thanks to all the panelists. This has really been a great review of the approaches to cybersecurity from those big three DER protocols that we see called out in IEEE Standard 1547. There's been some great questions and dialogue here along the way. So as John said, we're going to kind of close out the workshop proper, but we're going to keep the line open here for a few minutes in case we missed any of those questions. But as John is kind of alluding to, if you found the workshop interesting, and as I mentioned before, be sure to check out our previous workshop recordings. Those are out on our website at dnp.org. And then in addition to these open attendance workshops, the DNP user group is hosting a series of technical training sessions that are available only to our members. So if you're not a member of the users group but are interested in maybe looking at those past training sessions or getting in on our future training sessions that we have coming up here in the future, reach out to us at membership@dnp.org. We can get you some more information. Sarah will work with you there to figure out how exactly we can best engage with you. So, and again, if you've got ideas about future workshop topics that you think would be relevant to you and your industry, or things that you have going on, problems you're trying to solve, please let us know about that. And that goes for the training sessions as well. If you're a users group member, if your organization or you personally belong, and you've got something you would like to see a more in-depth technical training on, we'd love to see those ideas as well. So again, thanks to all of our panelists, thanks to all of our participants who dialed in this afternoon. John, thanks for leading us. You're an expert moderator, and we're glad to have you here. So we're going to go ahead and close things out officially, and we'll just we'll have our panelists stay online in case there's any last-minute questions we want to sneak in here at the end. So thank you very much, everybody.
Yeah, thanks, James. So we could just have an open kind of a fireside chat type of format, informal format, for any of you that have some additional questions or concerns. Does anyone want to start?
Hey, John, question.
Yeah.
I mean, when any of the DER devices, it could be EVs, inverters, or even solar, is there any kind of registration with the gateway or even with the utilities that, hey, I am online, now I can start communicating with you?
Think what you're talking about is a kind of a self-description, as has been talked about with IEC 61850. Generally speaking, I haven't seen that being used too much for any of the protocols that we're talking about, but I'm not an expert on 2030.5, so there may be something happening there. There will be, as part of AMP, a kind of a hello message that it comes up and says, hi, I want to talk with this network. But in terms of self-description and saying what points do I support, what data do I support, and all of that kind of thing, that's a bit different. You can certainly, it's certainly easy. Hey, I want to communicate, and I want to communicate securely, and here's my credentials and that kind of thing. So that certainly happens. But in terms of, say, in DNP, the SCADA part of the protocol, that is still more or less going to need to be configured. There is things like DNP XML files and so on, but not the kind of self-description that IEC 61850 has talked about. And as a matter of fact, as I understand it, they're not using it that very much these days. They're mostly using SCL files to set things up. So yeah, it's not exactly plug and play.
The SunSpec,
Got it.
the SunSpec profiles, you could use them for that. They don't enforce it or anything, but there is kind of a way you can interrogate a SunSpec device to determine, hey, what is it? What communication's there? But there's no, outside of the cryptographic handshaking that goes on or anything like that, anything at the application layer, the user would have to implement. But again, through profiles like the SunSpec profile, the information is there at least through the Modbus map.
I should mention in 1815.2, which is not the security part of the protocol, but there is the standard that has just been approved for basically the data model, has in there counts of how many meters, for instance, and how many DER units that you have and which functions that you support. But it's not a guaranteed matchup on exactly which points that you're going to get out of that. But it's certainly something that would help during the configuration stage. Sorry, I interrupted you, Robby.
Yeah, no worries. I was just going to say with 2030.5, it's I think it's pretty complete in terms of Everything is supported through device and service discovery, and then all of the information elements are self-describing. So you can very much kind of dynamically learn the support of a device. I mean, just to take a DER as an example, because 2030.5, kind of like DNP, addresses a lot more than just DER. But using DER as an example, I mean, it's everything from, the settings and the nameplate ratings, et cetera. There's a way to describe which are supported. There's a way to describe the control modes that are supported. There's a way to identify all of the different reading types that are supported for metering or metrology type reading, all the way back to, with a given server, you can do all sorts of service discovery. So quite a lot of work went into 2030.5 when it comes to device discovery, service discovery, and the information elements being self-describing.
All right. Thank you, everyone. I mean, I can definitely relate back to the old days, like AMI 1.0 and the ZigBee, where we used to provision those devices and then use some kind of security credentials to complete the registration and then start either communicating or getting the diagnostic. So just curious, now that we are in IEEE 2030.5, like 1815.5, and so many behind the meter devices. So how does this whole discovery works? Yeah.
So with 2030.5, it really depends on the endpoint you're talking to. So let's say, if you were just talking to a single inverter, there wouldn't be much to discover other than that single inverter itself. But from a DER perspective, there is a concept of exposing the internal DER units that comprise the DER system. So say you had, something like an EMS or a plant controller, and behind it you had a lot of, batteries and and solar, et cetera. With 2030.5, you can discover all of that if that's what's desired, if that's, what's allowed by the DER operator. And similarly, these things can be aggregated together in the information model. There's a way to aggregate DER at a premises level, as well as at a at a larger level if you want to do like a virtual power plant. And with aggregation, depending once again on the operator's preference, you can expose the members or what comprises that aggregation.
Absolutely, Robby. I mean, yeah, in cases of aggregation, orchestration, I mean, you need to have that kind of visibility, right? How many devices are there? What is the hosting capacity? Whether those devices online, offline. I mean, yeah, you're absolutely spot on. So look like there are some provisions to discover some of those devices.
Other questions, comments? Really good opportunity to pick the brains of our panelists here with a lot of experience.
Hi, I'm Alka from Pacific Northwest National Laboratory. And I had a question in the chat. So I have worked on DNP3 mostly here, and I've done the integration with Common Information Model for DNP3. And I just wanted to learn if other standards, I think 2030.5 also we did some integration with Common Information Model. So is Modbus has been integrated with Common Information Model yet, or is there any work being planned, or any other standard, not just SIM? So.
Yeah, I can jump in there.
Yeah,
So each of the different communication protocols are they're harmonized to some degree. Part partially thanks to 61850 but also 1547. So since 1547 specified certain capabilities, in order to sort of stay on the list, you had to implement those parameters, which forced them all to be harmonized to some degree. In 1547.2, which is it's just a guidebook, there is an annex that goes through the mapping of the 1547 requirements back to SIM. But the 1547 capabilities, it's just a subset of what each of the protocols support. So I'll have to defer to some of the others about like 23.5's demand response capabilities, or Grant may want to comment on some of the broader capabilities of 1815.2, because there's a lot in there beyond just what 1547 requires.
Yeah, there's a chapter in 1815.2 that basically shows which subset of 1815.2 correspond to 1547. But going back to Elka's original question, which is about SIM, SIM is like a couple of layers, couple of steps removed, I think, from most of these protocols. As Ben was just mentioning, there's a correspondence that kind of shows SIM mapping to IEC 61850-7-420, and then there's usually a mapping somewhere of 420 to DNP3 or 2030.5 or whichever. I think what's really good is that there is a consensus behind all of these as to what are the common functions that are supposed to be provided by a DER. And for that, Ben, I have to give a lot of credit to EPRI. Before any of these protocols were looking at DERs, EPRI was doing the common functions document, the common DER functions document, of which we're up to like version 5 or 6 now or something. EPRI started that as an EPRI project and then brought that in and looked at the mapping of how that stuff how those common functions could be created. And then there was the California Rule 2021 work that was based on that in turn. I guess what I'm trying to say to you is that, yeah, you can't really look at any of these and say, yes, they tied. Like if you look at all of them, you will find common functions and common data and so on. And I think the EPRI foundation of that has a lot to do with it, and it led to 1547.
Regarding 2030.5, when it comes to like the DER functions themselves, it's like all the others, mapped to 61850, 7420. So I think there's a lot of good harmonization there and reuse there. For the other aspects of 2030.5, given our motto, don't be weird, and we were trying not to reinvent anything, most of the rest of 2030.5 came from the SIM. So if you look at, and granted, the SIM has evolved since that time, so I'm sure they're not one-to-one mapped anymore. Nothing stays still. But if you look at, for instance, the way metering is done in 2030.5 with reading types and all of that, it's virtually identical to what was in the SIM at that time. And if you go to standards.ieee.org/downloads, you can actually download the UML model for 2030.5, and then you'll see that it makes it pretty easy then to do the mapping in Enterprise Architect, for instance, against the SIM. And that same UML model, the 2030.5 working group, literally takes that UML model, pushes a button, and that's how we get our schema, our XML schema that's normative to the standard itself. So there's a pretty tight mapping back to the SIM from 2030.5, but that was a tight mapping a decade ago, or more than a decade ago now. So I'm sure as all things go, they might have diverged some, because for certain the SIM continuously moves and changes, and 2030.5 has tried to hold the line of backward compatibility.
I'll inject a comment if I may. One way of looking at it is that these three protocols we've talked about today are speaking to devices in the grid. And SIM is generally regarded as a standard for talking about the grid. So the mapping from 61850 data models to SIM is largely considered as a way of taking the representation of data gathered from the grid into a model and then mapping that model to SIM, which talks about how that data works with the grid. So it is really two layers of abstraction separated. And I think people sometimes look at SIM as if it was actually a communication protocol rather than a method for modeling the grid. So sometimes they fit together quite well, and sometimes they don't fit together well. But I know that the IEC has some people who are interested in harmonizing the models from 61850 to the way that SIM represents the same assets.
Trying to dig up, there was a SIM model that was produced. We had a project with a number of utilities where they were looking to build systems for keeping the records of all the different DERs that may be installed. And there was a model that they had built as part of that project to store all of the settings and other information. And I'm having a hard time finding it, but as soon as I find it, I'll throw it in the chat. So that's a little bit different, I think, than what you're asking for, but it's the type of thing that you may want to implement in an enterprise level system that may be handling information describing DERs.
Thank you so much, everybody.
Other questions, other comments?
So one general question. I know IEEE 2030.5, which adopted Smart Energy Profile 2.0, and we don't hear 2.0 anymore. We constantly hear 2030.5 versus DNP3 and IEEE 18.15.2, but we are keep hearing multiple terminologies like DNP3-SL. I mean, what's the relation between IEEE 1815.2 and DNP3? When would we use one common terminology?
Okay, let me try to straighten that out a little bit. IEEE 1815 is DNP3. That is the basic SCADA protocol, which is in the process of being updated. Onto that, there have been the security layers, and they've generally been described as chapters within that standard. So when we talk about DNP3 SAV5 or the new terminology DNP3 SL, those are not really they're options that are specified within 1815. And then if you look at 1815.2, it is not a security standard. 1815.2 is a DER standard. So it is saying, given DNP3 before this had never really talked about point maps, about saying this is the data that should be carried on DNP. DNP had always been discussed as a pipe for SCADA data, and however you wanted to arrange your SCADA data was pretty much left up to the utility. But with the advent of DERs, what was needed was basically a data model, our first real data model that says this is what a particular application, DERs, looks like when you model it in DNP3. And so 1815 is the core protocol. It has as an option within it security. And then 1815.2 is the DER data model, which can be applied on top of your basic DNP and say, these are the points, the data points, and the processes that are modeled for DERs in DNP3. So yes, I can understand the terminology gets a little confusing, but hopefully that helps clarify things somewhat.
Oh, absolutely. Thank you, Grant.
Anything else?
John, we'll be sending out the chat records as well with all the questions that have been going on in that when we send out
Okay.
the recording. So if anyone has any last minute questions too, they can put it into the chat.
That's a good point, Sarah. Yeah, in addition to the recording, you will see all the questions in the chat and the responses to those questions. It's a good reference for you too. But we still have a few minutes if you want to ask some questions. All right, well, looks like everyone has their questions answered. So again, appreciate especially the time for all of you that participated today, and the questions that you asked. In panel sessions that I'm involved with, I always after the panel session, the attendees always say, I learned much more from the interaction with the panelists than I did with the presentations themselves. So it's always the interaction which is very rich in content. And so we really appreciate the interaction, not to avoid lectures and to have more of a workshop type environment. So thank you. I don't know, James, do you have any final words that you want to say?
Nope, just to say thank you again for everybody being here, and to our panelists and to you, John. Really appreciate it. I think it was a great session, and I think we're all looking forward to the next one. So,
Thanks again.
James and
Oh,
John,
yeah.
and to everybody
Yeah.
else, sorry about the ding dongs that were happening. We're learning about how to present these workshops online. And there were a few people that, we had over 100 people attend this presentation, which is amazing considering there were a few issues with the registration. So there were quite a few people that weren't able to get in, and we're going to investigate that. We did have over 300 people register. So everybody will be getting a copy of the recording once we edit it as soon as possible. And please, we look forward to you joining the next ones, and hopefully the ding dong won't happen.
it's great. Well, thank you very much for your help behind the scenes, Sarah.
Yes.
Thanks, y'all.
Thanks to you, James. Thanks very much. Thanks to the panelists.
Thanks, y'all.
Thanks, everybody.
Have a great
Bye-bye.
day.